You ask a modern AI a hard question, and for a moment, it just pauses. Thinking? It says something new is happening in that pause. The model is reasoning before it answers. So today, let's look inside the pause and see why thinking models are different. To feel what changed, start with the old way. A normal model answers in a single shot. You type a question, and it immediately starts predicting the next word, then the next, straight through to the end. There is no pausing and no planning. It simply blurts out the first response that comes to mind, and for a huge number of questions, that works beautifully. But give it something genuinely tricky, and blurting falls apart. Take a simple one. How many times does the letter R appear in the word strawberry? A fast model, answering on pure instinct, will often just say 2 confidently and wrongly. It never slowed down to actually check. The fix sounds almost too simple to work. Instead of demanding an instant answer, you let the model think first. You ask it to write out its steps before committing to a final reply. And that one small change is the whole idea behind a thinking model. Watch what happens now on that same question. The model spells the word out, letter by letter. S-T-R-A-W-B-E-R-R-Y. Then it scans through, looking only for the letter R. It finds one near the start and 2 more at the end. It counts them up. 1, 2, 3. And now it answers 3 correctly. Each little step written out like that is called a chain of thought. So why does simply writing the steps down help so much? Because each single step is tiny and easy to get right. And once a step is on the page, the model can read its own reasoning back and build on it, or catch a slip before it hardens into the final answer. In a real sense, the model is thinking out loud and then thinking about what it just said. This extra effort has a name. Test time, compute. Training is the effort spent building the model once up front. Test time is the effort it spends every single time you ask. A thinking model simply chooses to spend more of that effort at the moment of answering, doing more work per question. And here is the result. That surprised almost everyone. The longer you let one of these models think, the more questions it gets right. Give it a few seconds and accuracy jumps. Give it much longer on a truly hard problem, and it climbs higher still. For years, the main way to make AI smarter was to make the model bigger. This is a second lever entirely. Think longer, not just build bigger. Better still, that thinking is a dial that you can turn. Want a quick reply? Keep it short. Facing something hard, let it deliberate for much longer. You are trading a little time and a little more cost in exchange for a more careful and more correct answer. And if this feels familiar, it should, because you do the exact same thing. Ask yourself, 7 times 8, and the answer, 56, just appears fast, automatic, no effort at all. Now try 17 times 24. You cannot feel that one. You have to slow down and work it out step by step. Psychologists call these 2 modes, System 1 and System 2. Thinking models finally gave AI a System 2. So, how does a model actually learn to think well, not by having humans write out every step by hand. Instead, you give it thousands of hard problems where the final answer can be checked. The model tries, reasoning its way through. When a chain of thought reaches the correct answer, that whole path gets rewarded and made more likely next time. Repeat that millions of times, and good reasoning gets reinforced. And the remarkable part is what the model teaches itself along the way. Nobody programs in the strategies. Yet, these models start to backtrack when a path goes wrong, to double-check their own arithmetic, and to try a different approach when the first one stalls. Those habits emerged on their own, simply because they led to right answers. One thing to know about what you actually see. Often, the full chain of thought stays hidden, and you are shown just a short summary, a little thinking label while it works. Behind that label, the real reasoning can run for pages. The deliberation is genuine, even when it is tucked away. These reasoning models are already here in mainstream. OpenAI's O series, DeepSeek's R1, Anthropic's Claude, with extended thinking, and Google's Gemini, thinking models. Different labs, same core idea. Reason first, then answer. So when is all this thinking worth it? It shines on hard math and careful logic, on writing and debugging code, on multi-step planning, the kind an AI agent needs, and on real science and analysis, anywhere that a single wrong step ruins the whole answer. But that thinking is not free. The answers come back slower because there is real work happening. All those extra steps are extra words, so it costs more per question. It can be overkill for simple things, and a model can even overthink a question that never needed it. Which makes the choice fairly simple. For everyday questions, quick facts, drafting, casual chat, a standard model is faster and cheaper and perfectly good. Reach for a thinking model when the problem is genuinely hard, and getting it right matters more than getting it right now. Now, one honest caveat: no hype. Thinking reduces mistakes. It does not erase them. A long, confident chain of reasoning can still march, step by careful step, straight to a wrong answer. More thinking helps a lot, but it is not a guarantee. Let's put them side by side. A standard model answers instantly, in one pass, cheap and fast. And great for easy questions. A thinking model pauses to reason in steps. It is slower, and it costs more, but it is far stronger on anything hard. Same underlying AI, two very different ways of answering. So, to bring it all together, thinking means reasoning in steps before answering. Test time compute is the lever. Spend more effort when you ask and get more accuracy back. They learn to reason through reinforcement rewarded for reaching the right answer. And you reach for them when a problem is genuinely hard. If this made thinking models finally click for you, subscribe. That's one concept at a time, here on Superintelligence.